Okay, this will be fun. Here I have a Palm Wonderful empty container. Now the one thing that's neat about these spherical shapes is they obviously act like magnifying glasses when you look at them from the other side. So inside is just regular tap water. And I have some special ferrofluid in here. You'll notice it doesn't look like regular ferrofluid. It looks brown and sludgy, kind of like molten chocolate. You see those two spots right there? I'll make mention of those in a minute. What can we actually say about ferrofluid and the geometry of magnetism and dielectricity? Let's first off with making a comment. Okay, a Gauss meter. As far as the flux reading, any Gauss meter will read really high in the center, intermediate zone right here, and really high on the edge. Same thing on the side. This would be the plane of inertia. Really high here, small intermediate, almost nothing, then really high right here. Same thing on the other pole, quote unquote. Okay, doesn't matter which pole I use for this one. So let's go along the plane of inertia, which is right here. Let me grab some magnetic viewing film so you can see the plane of inertia. Check that, some strips right here. You see that? You can see it right along the center of the magnet right there. Pretty evident, right? Okay, see that? Okay, now we're looking at this. Okay, so we should see a cross-section, we can already see that too, of a hyperboloid and a torus. We actually draw a cross-section of a torus, since we're actually looking at a flat bulge of my ferrofluid. I should call this chocolate ferrofluid. That's exactly what it looks like, doesn't it? Looks like molten chocolate sludge. Maybe it looks like a pile of poo. It kind of looks like that. There's just a little air bubble in the top. No big deal there. You notice if I actually press in a little bit, you'll actually see the geometry of the magnet. As long as I get it right there. There we go. So the lens looks perfect. There we go. Now you can see the hourglass shape better. Do you see that? Okay, what are we looking at right now? We're looking at a hyperboloid. What's the inverse image of a hyperboloid? That'd be the torus, or the toroid. So right now we're looking at the negative image of a torus. We're looking at the hyperboloid. We're looking at the cross-section of the magnet along the plane of inertia. Right? Have high magnetic flux right here. Low at the center. At the center of any magnet, there is almost no magnetic flux. Right here there is a centripetal convergence. Here is centrifugal divergence. I seem to confound people with these words that are really so commonplace. Everybody should know the words centrifugal, centripetal. They should know the words convergence and divergence, certainly so. So, here we should see a different geometry by pressing down. Let me rotate this over to the clear side. And there we go. I'm trying to see that? Now, according to any Gauss meter, the center of any magnet has a very high flux, just like it does along the centrifugal edge. That's because the Gauss meter doesn't differentiate between centrifugal divergence and centripetal convergence. Okay? Let's place it here. Press down a little bit. Actually, it didn't even require any pressing down. You see the torus we're looking at right here? We're looking at a donut, aren't we? I'm actually able to point the camera in a little bit more over top of this. You'd actually see the full donut on this side. This is a wonderful little container which had pomegranate juice in it. There we go. Let's use the smaller sphere for this. Just ignore the air bubble in the top. This is a smaller sphere. Harder to press down. This is a larger sphere. It's easy. Okay. See that? Donut. This is the torus. Everything, all this nanoparticle mix of ferrous material in this special ferrofluid mix is accelerating out towards the centrifugal edge. Now the question remains that there's no branch of science in any book on magnetism that differentiates out centripetal from centrifugal. So why is there no ferrofluid in the center here? The closer I'm able to get it, the more the hole expands. The more it defines a donut. Even just laying it right here on top with no pressure at all forms a donut. All I have to do is actually change the viscosity of my ferrofluid in this tap water solution to actually show the geometry of dielectricity versus magnetism. Right now, we're looking at the donut of magnetism. Now we're going to look at the torus, the donut. Okay, most people don't know what a torus is. I hope most people should know what a torus is. Now, along the plane of inertia, we're looking at the hyperboloid of dielectricity. This, folks, listen, I'm going to repeat it twice, maybe 3 times. This is Mother Nature's geometry of counterspace. Hyperboloid. Look up that word, okay? Hyperboloid. Hourglass shape. You see the hourglass shape, boys and girls? Do you see it? Do you see it? Do you see the hourglass shape? The harder I press, the more it forms an hourglass. Oh, yes. There we go. This is the geometry of counterspace. Was that pretty simple? Was that pretty simple? By the way, no one's actually seen this before because ferrofluid normally doesn't act this way because it has incredibly high viscosity. This is a very low viscosity ferrofluid mix. So, geometry of counterspace, dielectricity. Perfect hourglass shape, isn't it? Actually, it would be a perfect hourglass shape if this magnet were larger in shape like a cube, but it's not. It's rectangular, so that's why it is not a perfect hourglass shape. But it still follows, let me bring this around. It still follows the perfect hourglass. This is the hyperboloid of counterspace. No one's ever seen a video like this before. Never. It doesn't exist anywhere on the internet. It doesn't exist anywhere on YouTube. Period. Period. Guess how I made this? I'm not going to tell you how I made this special ferrofluid, but I used tap water and a pomegranate juice bottle. Because these little bulbs act like magnifying glasses. See that? Something else neat. I'll have to explain it later. Maybe you could take a guess at it. If I drop the ferrofluid, watch how it falls when I actually take the magnet. Now we're using one pole with the magnet. When I let go of this and let it drop to the bottom, watch how it falls. Actually, I have to bring it up right to the top like this. Okay, let's watch again. Let me get a view of the camera. 1, 2, 3. Now, if I actually bring it over along the plane of inertia, it'll always form a cup shape. The unfortunate thing is they have the camera directly over top of it, so I can't lift it straight up really fast without hitting the front element of the camera lens. But, see that? Always forms that. So, what have we learned here? Using this viscous ferrofluid mix and simple tap water. Oops, let me bring it over like this. See, the closer I get it to the plane of inertia, right now, the closer I get it, the more you'll see the geometry of counterspace right there. There you go. The hyperboloid. Field pressure mediation. You see, the universe and Mother Nature are really goddamn simple. Everything works off pressure mediation. What's pressure mediation mean? No difference saying pressure mediation than saying water flows downhill. Yeah. You see this? What are we looking at now? We're looking at the cross-section of an hourglass, a hyperboloid. Now, we're going to look at the cross-section of a donut, a torus, right? Donut / torus versus the geometry of counterspace. Listen closely. This is the end of this video. I want you to pay attention. This is the geometry of counterspace. This is the geometry of space. This is force and motion. This is space. This is inertia and acceleration. This is counterspace. Yeah, girlfriend, you saw it. So, this is the world's first video. Simplicity is divinity. Man, oh man, it doesn't get any simpler than this, other than my special mix of ferrofluid here. This is a pomegranate juice bottle. And tap water. Yeah. That's right, girlfriend. Thank you so much for watching. This is the world's first. No one's ever shown you this before. If you like this video, you could drop a buck or two in the link below. You can tell me to jump off a cliff, but this is definitely a first. And boy, oh boy, it doesn't get any simpler than this, does it? Thank you for watching, okay? Adios, hasta luego, aloha, do svidania, and увидимся. Bye-bye.